So in addition to being able to write equations of the sine and cosine function when we know the amplitude, period, phase shift, and vertical shift, we also want to be able to sketch a graph of those functions. What you see on the screen right now are two graphs of the sine function, and what we're going to do with that is I'm going to write another equation, and what I want you to do is on top of that graph, we're going to show how that's going to transform the original function of the sine. For example, let's say that in this first graph, we ask you to graph y equals 3 times the sine of x. So when we're sketching 3 times the sine of x, what we know is that our amplitude is 3. Nothing else changes. It's still just a regular sine of x. So that means instead of having a maximum here at 1, my maximum is going to go up to 3. And instead of having a minimum at -1, my minimum is going to go down to -3. Same thing happens on the other side of the y-axis. So we're going to go up to 3, down to -3. And then once we've plotted a couple of points, we're going to trace that graph. And then we have our new function with our amplitude of 3. In addition to changing the amplitude, maybe we have another change and we're going to graph instead y equals the sine of 2x. If I change the number in front of the x, remember that that's changing the period. The period by definition is 2 pi over b for our sine and cosine functions. So in our case, our period is 2 pi over 2, or in other words, just pi, or 180 degrees. Now, what I like to do when I'm sketching them, particularly if this was something that was on a quiz, just kind of helps you to keep track and me to know what you're trying to draw in case the lines get a little bit off. What this means for us, remember, is that if your period is 180, this goes through 2 cycles in the span of time that the sine previously had gone through 1. And this 2 is what's helping to tell you that, right? This goes through 2 cycles. And so what I like to do is to say, normally we would go through 1 cycle by the time we start at 0 and end at 2 pi. And so what I'm going to do is I'm just going to split that in half and draw a little line segment in here at pi. That's not part of our graph of the sine of 2x, but it's just telling me, hey, I need to go through 1 whole cycle by the time I get to this vertical line. And then I need to go through another whole cycle by the time I get to the next vertical line. So my maximum and my minimum are still at 1 and -1. That hasn't changed. Up to 1, down to -1. But now instead of taking 2 pi to go through 1 cycle, I need to get through 1 cycle by the time I get to pi. And now I need to do that again. Go up to 1, down to -1, and then back again. So now we've shown you that I've gone through 2 cycles in the span of time that previously I had gone through 1. You can see that my period is now 180 degrees. I can draw it on the other side as well. So I'm just going to split that in half. Again, I'm going up to 1, down to -1, and back. I maybe should have drawn my dots on this side so that it was a little more uniform like it was on the other side. Up to 1, down to -1, and back again. So there's my graph of the sine of 2x. The next picture that you have has the cosine graph on it. And so when I look at the cosine, same idea happens in terms of when I'm going to be switching the amplitude or the period. I'm going to show how many cycles that I've gone through. So maybe on something like the cosine here, if I was going to do y equals the cosine of 3x, what does that tell me? Now I've gone through 3 cycles in the span of time it used to take 1. So your period is 2 pi over 3, or 120 degrees. And so what we'll do is we'll split this nice and even into 3 separate sections. And so that means that my cosine, again, starts at 1, down to -1. It's got to go through 1 cycle by the time it gets to that dotted line. Another cycle by the time it gets to the other, I said dotted, but I really meant that vertical line there. And then 1 more cycle by the time we get to the end. That one didn't go quite far enough down, but I think you get the idea. So again, we're using these vertical lines just to help tell us, hey, this is where we're going to split it. So it's not actually part of the graph, but helps to show me that that's gone through 3 cycles. Now, so far we did each of those individually, the amplitude and the period. We could do some combining together of those functions. So let's say on our last one here, we want to graph y equals 3 times the cosine of 2x minus 1. Now, if we're going to do all of those things together, let's take it piece by piece. I'm going to start with the 3. If that 3 was out front, that means typically you would have a maximum that would be at positive 3, and you're going to have a minimum that's going to be at negative 3. Now, with that, what we are also seeing back here is that we have a minus 1. Everything is shifted down 1 unit, which means my maximum that was at 3 is now actually at 2. And my minimum that was at negative 3 shifts down 1 unit to negative 4. So the cosine typically starts at its maximum here and then goes down and then back up again. So instead of starting at 1, like the graph of the cosine did, or 3, like the graph of 3 times the cosine would, we're going to start with a maximum of 2. Now, the only other part that we haven't considered yet is that we have a 2x in here, and that's impacting our period. So remember, that means that we're going to go through 2 cycles in the span of time that we normally would go through 1. So I'm going to, before we get too far, just draw a dotted line in here to help keep myself organized. So I need to go through 1 cycle by the time I get to that dotted line so that I've gone through 2 cycles altogether. Remember that we're starting at 2, so I'm going to start up here at 2. That means I need to go down to negative 4 and make my way back up to 2 by the time I get to that dotted line. It gets a little bit squishy in here, but I think we can follow that along. So here's our stretched out version of the cosine. Again, we're going to go down to negative 4 and back up to 2 in 1 whole cycle. And there we go. We could do the same thing for the negative part of our x-axis as well, but hopefully we can see how we have an amplitude of 3. We've gone through 2 cycles in the length of time that we have here from 0 to 2 pi, and we've shifted everything down 1 unit.